All right, time to continue. I'm going to change this to say 3.5. And what we're doing in this one is derivatives of other trig functions. So the derivative of tangent x, we're going to work it out. Tangent x is sine x over cosine x. So we're going to do the derivative that way. So this is going to, again, this is going to be a quotient rule. So the high term is sine x, the low term is cosine x. So the derivative of high is sine x, derivative is cosine x, and the derivative of low is the derivative of cosine x, which is negative sine x. And so we start filling stuff in. We have cosine x, this is low, times the derivative of high, minus high, times the derivative of low, and down here we have low squared. So you'll see the two negatives will cancel each other out. We'll have a positive there. Cosine x times cosine x is cosine squared, and sine times sine is sine squared. And this top actually is the Pythagorean identity. That equals 1. So we have 1 over cosine squared x, and I'm going to write that a little bit differently. This is like 1 over cosine x squared. And that way it might be a little bit easier to see that that is secant x. And since it gets squared, we have secant squared x. Another way to do it is to split up the fraction. Okay, so if you split up the fraction, we do cosine squared x over cosine squared x, and then the plus sign here breaks up the fraction. And we have sine squared x over cosine squared x. Cosine squared x over cosine squared x just cancels. We get a 1. Sine squared x over cosine squared x is tangent squared x. So this is 1 plus tangent squared x. That's another derivative of tangent x. But this allows us to see that secant squared x should get us to be the same value as 1 plus tangent squared x. We did that a different way in the worksheet based on working off the sine squared plus cosine squared equals 1, but we just confirmed that identity here. Doing similar methods will confirm the rest of these other derivatives. We have the derivative of tangent x is secant squared x. The derivative of cotangent x is negative cosecant squared x. And then the derivative of secant and cosecant are weird. They include themselves. The derivative of secant has a secant in it, but it also has a tangent x on it. And the derivative of cosecant x has a cosecant x in it. It also has a cotangent x, but it's also negative. So these two have a negative sign. They're a little sneaky. You got to remember them. One way to remember them is when you take the derivatives, and you will see this if you look up above at cosine. Right here, cosine starts with C, it has a negative. Cotangent starts with C, it has a negative. And cosecant starts with C, and it has a negative. If you take the derivative of a trig function that starts with C, it's going to have a negative. d dx of a trig function that starts with C is negative. Okay? We'll take a look at some examples. I want you to try to find the derivative of f of x if f of x equals 3 secant x minus x cotangent x using those formulas we have up here. Pause the video and try to work them out. All right, the secant x was straightforward. We take the derivative of 3 secant x and we will get 3 secant x tangent x. The x cotangent x, we've got a product. Look at that, Sneaky Jones again. So we got to use the product rule. And when we do that, we get rid of the x. The derivative of x is 1, so cotangent x is what remains. Remember, this negative has to be delivered or distributed to both terms. When we take the derivative of cotangent x, we have negative cosecant squared x. It was also negative from the distributing the negative sign, so those will turn into a positive. And we should end up with 3 secant x tangent x minus cotangent x plus x cosecant squared x. Okay? Next question. Find the equation of the line tangent to f of x equals secant x at x equals pi over 6. Pause the video and try to work this out. Remember, in the past, we took the derivative to find the slope of the tangent line, and we're going to do the same thing here. All right, I will assume you did that. We need, the derivative is secant tangent. We do need to write the line. We're going to be doing y minus y1 equals m times x minus x1, which didn't write very clearly there, so let me write it where I got a little bit more room. Which means we not only need m, we need x1, y1. M we can find here. That's going to be our m when we plug in our x. Our x1 is going to be the pi over 6. To find y1, we got to plug it in. F of pi over 6 will be y1. So that's secant pi over 6. And if you do it, if you want to do it in a calculator, you got to do it like this. Do 1 divided by cosine of it. But I try to use values where you don't need a calculator. Cosine of pi over 6 is square root of 3 over 2. And so we just end up flipping the fraction over because it's on bottom. And I rationalize to go from 2 root 3 to here, multiplying top and bottom by square root of 3. Rationalizing the denominator. All right, so now that's a 2 root 3 right there. We've got our point. We've got our slope. If we plug in pi over 6, we have secant pi over 6 times tangent of pi over 6. I left them unrationalized at first because I wanted to see if anything canceled, and it did. Secant is 2 over square root of 3, and tangent is 1 over square root of 3. So when I multiply them, the square root actually goes away, and I don't need to do the rationalizing. So m is going to be 2/3 there. So we're going to take this, and we're going to put it in there. We're going to take these and put them in the equation. When we do, we get y minus 2 root 3 over 3 equals 2/3 times x minus pi over 6. And we do some distributing, and we move the negative 2 root 3 over 3 to the right. All I did is to get a common denominator right here, and that way I could put them all as one big thing added together, but you don't technically need to do that. It just looks nicer. And now I'll pause this video. Looks like we're doing higher order derivatives next. Peace.